Today I'm going to talk about the DSLs, which are a wide group of languages. So I will focus only on group which may be associated with one of the most powerful JVM languages, Kotlin. So maybe a few words about me at first. My name is Artur Czopek. I still work as a Java developer at Microsoft. And currently we're introducing Kotlin to our application. So it's a big step for us. In my free time, I write a lot of code in Kotlin because I really believe in this language. And in my free time, I write a blog, simcoding.pl. And unfortunately for you, lots of content there is in English language. But for you, I have something special. During this presentation, in the upper left corner, you will see a link to my blog where you can receive additional resources about Kotlin, about DSLs. So if you want to learn something more, I encourage you to check it. Also, I'm going to tweet under Devoxx Kotlin DSL hashtag later. So you will find their whole sources. So maybe a few words about DSL at first. DSL is a shortcut from domain-specified language. Probably you may be aware that DSLs are dedicated for solving particular problems. You probably know also that languages like HTML, CSS, or XML are also DSLs. And DSLs doesn't have to be a standalone languages. You can create your own language, your own DSL in other language, if it's possible, of course, like in Kotlin. A few examples of DSLs. You know probably how HTML looks like, so I will show you two examples in Kotlin. There is the first one example of DSL when you can create routes in Spring 5 framework. It is, of course, written in Kotlin. It is in external library. I think it's really readable because you can really easily notice what routes are defined there, what they called, what they returns. Also, you can nest their other routes. I'm not a big Android developer, but I think we all know that Kotlin is widely used on this platform. So there is another DSL for creating activities. It's something like, let's say, page in Android. If you don't know, you can easily also see there what elements will be there. So I think it's another nice DSL. But why should we use DSLs, if possible, of course? As I said earlier, it's more readable than imperative code. I think that if you know someone who is not a developer and would see this code, he would probably understand what's going on in this code. It is easy to use. I mean, if you have a DSL in other language and you don't have install other libraries, etc., you can just write. It is effective. I mean, also, if you don't have to create your DSL by your own, you just write your code and it usually works with other codes. And in some languages, it is easy to extend. Like in HTML, you can add other attributes to some tags. You can even create your own tags. And in Kotlin, you can extend other DSLs without problem. But why Kotlin? It's a perfect connection with DSL. In Kotlin, a function may be passed as an object. You may assign to some variable or value in Kotlin function. You can define function inline, and also you can pass a function as a parameter to other function, just like, for example, in JavaScript. It is widely used to implementing higher order function pattern. Name and default parameters in Kotlin. I mean, if you have, for example, function foo, which receives 3 booleans, you would probably call this function like foo, true, true, true. So it's not readable at all, right? You can, in Kotlin, explicitly type what is this parameter. If you have, let's say, 3 parameters, and first it's called 1, 2, 3, you can type 1 equals value, 2 equals value, 3 equals value. So it's not a problem. And default parameter, I think that it's more intuitive for you. You can, in function, define what is the default value of this parameter. And the same applies to the constructors in classes. Infix functions. It's more like syntax sugar in Kotlin. If you have a function in Kotlin which receives only one parameter, you can type it like, let's say we have function on integer which is called plus and receives another integer. You can type like 2 space plus space 2. I will show you later, of course. Yeah, this is an example which I've written in bad point. Extension function in Kotlin, it's one of the most powerful functionality of this language. You can easily add other function to class, even if you don't have an access to this code. You just define it as a other function with one difference. You need to precede this function by a class name. I will show you later, of course. And lambdas. Probably everyone knows what lambda is. Difference is in Kotlin that you can also define receiver. Receiver means that you can define on which context past block of code may be called. In other words, you can define on, let's say that you won't only call some functions on list, so list class. So it's not a problem. You can easily define it. And okay, there are lots of stuff. Probably it's not easy to understand for you now. So I will create one DSL and I will show you how to really easily create it in Kotlin. It's okay, this size? Okay, perfect. So yeah, we'll create, it will not be something like, wow, I will just create simple console application, which will have simple tournament where we have heroes which can battle with each other. There is a simple model when we have, as I said, hero. Each hero has a name, some profession, which may be a knight or wizard. Also, each hero has a level, which will be increased automatically after each battle, which he won. And also, each hero has equipment and spells, which are a list of simple elements. Also, there is a power, which is calculated lazy by Kotlin. I will show you implementation soon. Items and spells also has a name and power. It works the same, almost. Battle is only the pair of heroes, hero 1, hero 2. And also, there is a winner, which is calculated by Kotlin. And tournament, it has only a name and list of battles. More advanced implementation looks like this. It's not the most important part of this presentation, but let's scroll it quickly. There is calculated power, equipment and spare power, which is calculated by the lazy delegate here. It's only calculated once when we refer to it. Level upgrade, item and spell still has only 2 parameters. Battle also has a winner, which is calculated by lazy. We'll use their power of heroes, but we'll add also their lucky multiplier, which will introduce there some random to these fights. And the same for tournament. We'll there fights in system like in the World Cup when you have pairs and there is some kind of ladder. Okay, so let's use the model and let's create minifier when we will implement first version of something like DSL, but it will still written in imperative way. So I will create main function. In Kotlin, we can define function at top level of file. We don't have to create any classes to it. So it's valid code. And I will create value tournament. Constructor is called without new keyword because it is not allowed in Kotlin. And there is a name and battles parameters which we need to pass to constructor. As I said earlier, we can use named parameters in Kotlin. So I can type name, and name of this tournament will be Devoxx tournament, let's say. And battles. I use it because you will see later that we're gonna use this feature more. I will use a list of function from Kotlin standard library, which receives, in this way I will create only one battle to make it easier to understand. I will show you more extended version later. So battle is a pair of hero. So the first hero is gonna be called Super Knight, let's say. I'm not so creative. And profession of this hero will be Knight. Level, let's say 10 at first. Equipment also is gonna be list of, in this case, it's gonna be item. Sword, power 10. And the second item is gonna be shield, maybe, power 5. And the same for spells, but since it's Knight, he doesn't know more of them. So weak spell, maybe it's called Scala, with power 3. Okay, and this hero is gonna fight with, it's okay, yes, it's okay, with another hero, which is gonna be called Gandalf, maybe, I don't know, any different wizard. And name of this profession is, of course, wizard. Also level 10. Equipment, I'm not sure what we can have. Rod maybe only. And also power 3, like spell Scala, also weak. And list of spells, 2 spells there. Let's say Java, it's a little better than Scala, but still not as good as Kotlin, of course. So I will create there 10. Okay, so it's still imperative code, but it looks a little, you will create probably something similar in Java, but it's still like this list of function name parameters, so I think it's looked better. So let's check if it's gonna work at least. So the winner is, and I will interpolate string there, because I can do something like this in Kotlin. I don't have to concatenate it. No name winner, of course. Let's try to run it. And let's see who's gonna win. Okay, this time Super Knight has won. Perfect. But now we need to make some improvements there, because like I said earlier, it's not DSL. We'll not start by creating DSL at first, but let's get rid of this, for example, at first, this list of creation. So we'll create extensions file when I will create some extension functions. But let's say that we want to create these battles by typing battles, and there we will type just battle. Also, the same should apply to equipment and spell. We want to type items, and there we pass another items as argument. So it's gonna be easy. It's gonna be even not the extension function, just tab-level function like list of. Let's say it's gonna be called battles, which receives var arg. Various amount of arguments in Kotlin is a keyword, and it is required. So we pass the battles, various amount of battles, where each will be of type of battle, and I will just type convert it to list. I can call this function, and it's still okay. I don't define a type what is returned because there is type interference in Kotlin. Also, if there is only one line and it's only returned, I can type it with equal sign. So it's called expression body. So I will do the same for items. And I will also convert items to list. And I will do the same for spells. Okay, let's try to apply it. I will only replace this calls. Oops, sorry. Okay. Items, spells, items, spells. Okay, it's not a big improvement, but it still looks better. Now we'll do some more magic. You wouldn't create it in Java, I'm sure. Let's say that we don't want to create battles by typing this ugly constructor and passing there 2 heroes. Let's say that we want to create in this way, like typing hero 1 space versus hero 2. So there is a simple example of infix function, and I will create a valid function to solve this problem. So I will need to use infix modifier, and it is required. And I will add this function. Let's assume that we don't have any access to hero class. So I will add this function to hero class in this way by typing class name, that, and name of this function versus. This function receives another hero, let's say opponent, and I will return their battle. So at first argument, I will pass this because this function is called on some hero, right? So in this way, in this case, this is this hero, right? And another parameter will be this opponent. So I can use it in this way, hero versus hero. I can remove this battle call, and of course this. And it looks a little better, I think. Also, let's say that we want to create items by typing sort power 10. We can do it to either. So, but in this case, I need to extend string class. I'm not sure if it's a good way to do it, but for demo purposes, I will do it. So I will add the power function, which I will call on string, and the first parameter later will be power, so it's gonna be in this way, some kind of int, and I will return the item. This in this way is some string, right? So I also pass this there, and power here. I will do the same for spell, but since they're the same signature, I need to temporarily change this call by like spell power maybe, and I will return spell there. It's not the best option, but I will handle it later. Okay, so there is item, power, and it's still valid, perfect. And for this spell power, free. Okay, and another hero, power, free, spell power. Okay, I will change it. Okay, let's run it. And now it looks a little better, I think, and it's still more readable. Code still works okay because we have still the same heroes, the same powers of these heroes, so it's cool. But as I said earlier, it's still not DSL. We want to create something like this. Don't look at this red color; it's not important. And I think it's more. You will see there similarities with the slides which I showed you earlier. Because we have this curly braces, some typing parameters, no constructors, no other things. So perfect. But how to create it? I will create another file, DSL, and it looks a little like some kind of builder pattern, right? Without this constructor. So we may create something like builder in constructors in Kotlin, but we cannot change values later, right? We need to define the constructor. But what if we want to make it later in builders? And how to not to lose immutability? In this case, we need to create another class, another build, the first builder in this case. So I create class tournament builder, which will have the same parameters as our tournament class. It's gonna be mutable for now name, which will be empty string. And I want to create private battle list, which will be immutable. I will show you soon why. But list will be immutable. List of battle. Okay, perfect. So as you may see, there is something like this notation this way, like tournament. And you wouldn't see something like this in Java, right? It's something like maybe lambda, but maybe argument, but there is still no curly braces. As I said earlier, in Kotlin, we can pass other functions and lambdas to functions as a parameter. So let's start maybe with buttons, which will be nested there. It's gonna be called like this, buttons, right? So I will create function buttons, which will receive some block of code. But how to define it? Maybe some demo on this name. Now, this name is only a string. But if I do it in this way, it's a difference. If you notice, there is some empty brackets, arrow, and string. It means that name is a function which receives nothing and returns some string. So let's create the variable new name maybe. And I will assign name to it. There's function assigned to value, right? But I can call it this function, and then it returns name. So if you know how can we define some block of code, I will pass the block of code as a parameter. And this block of code receives nothing, and this block of code also should return nothing, because we won't call something like add functions on list, right? Unit is something like void in Java, just to let you know. Okay, but how can we add some battles to our battles list? So it's maybe problematic, right? Because we can pass there any kind of block as we want. I mentioned earlier about something like receiver in these lambdas in Kotlin. So I can type something like this: mutable list, battle, And this means that this block of code will be valid only on object with this type, mutable list of battles, right? So I could type something like this, battle list block, and it will call this whole functionality of this block. But there are two problems. The first one is that I still need to type in this battle something like this, add battle, yeah? So still it's not look like DSL. Also, since I called this block of function block on this battle list, it returns us some kind of only unit, so returns nothing, right? It will call and that's all. But we still want to refer to this list. So the first thing which we need to do, we need to, let's say that we want to make that this versus previous call, hero versus hero, should add this battle explicitly to our battles list. So to do it, we create another class, battles, which will extend array list of battle, and there I can define this, I can just copy this function, and I will implement their different behaviors, because if I call this function only in context of these battles, it will work differently in this case. So I will create their still battle, but I want to add this battle to my list. And now, since I have this class, I can change their context. And thanks to it, if I call versus in this context, it will call this odd. I don't have to type it. But to call this block of code and to return still our battle list, I need to call apply, and there I can pass this block of code. Of course, no battles, but battles, I need to create this new instance of this class, this array list, apply this code, but this array list of battle, not mutable list of. And to do it, I can call battles list, add all function, and it will just add our full content. And last thing which we need to implement in our builder class, of course, function build, which return valid instrument of tournament with immutability values. So it's gonna be name and battles list, battles list. And of course, I didn't remove lambda there yet. Oh, yeah, of course. And now we don't have yet this tournament call. I will create this at top level function, which also receives block of code, and you probably know that this block of code will be called on tournament builder context, and returns nothing because we want to do it something here. I will create new instance on tournament builder. I will apply block of code, which will be equals this battles and this assigning to names, and there I will call build. And this function returns as new instance of tournament. Okay, we have first steps implemented there, so I will try to use it there. I will call this in this way, as this tournament. If you don't know how I omit this brackets, I can do it also in this way, but Kotlin's IntelliJ shows us that I can move lambda argument of our parameters, because if you have lambda as a last parameter, I can move it out of our brackets. And it's valid and it's preferred in Kotlin. Okay, it's still valid, but I need to remove this comma because there is not parameter of constructor, but another call in this block of code. And battles will be called also in curly braces. Okay, and if I go to the versus, there is used this implementation within battles class context. This extension is not used anywhere, so I can remove it. Also, this battles is not used anymore. And let's run it. Let's see if it works. Yeah, it still works. This time Gandalf has won. And still powers are the same, levels are the same, so perfect. It still works for our one battle. Now I need to do the same for hero, so to not waste your time, I will just use prepare snippet there, and I will change one thing to show you. I will still do hero builder with name, profession level, and all these default values, because I don't want to make their nullability. And also extended array list for items and spells. But I will remove their name and profession, because I can change it However I want, I can just leave it, and I want to make it as immutable there, but I need it, I will make it required in this case. Since it is in constructor and this type is explicitly defined there as not nullable, to make it nullable I will need to type there a question mark. To make it nullable I will type it in this way. And since I type it in this way, I need to use every time profession and name. So it's gonna be a little different. I still can refer to name and profession. And still I will not create one top level hero function. I will create function knight and wizard. Also, this function will not receive only block of code, but the first parameter will be name. And the second parameter will be not profession, because I will pass there later, depending on function which I will call. But I will type there block of code. It also could be on specified context. In this way, in this case, it's a hero builder, and still it returns nothing. Let's create a new hero builder. It needs two parameters, so name and profession, in this case, in this knight. Again, I will apply code, and I will build it. Last step to creating DSL, will do the same for wizard. Difference is that I will change their profession, and I will try to implement it here. So super knight is a knight, of course, so it's gonna super knight. I will pass it as first parameter, and the second parameter is block of code, so I can type it out of brackets. Name is type above. Profession I cannot also define it. Lever here. We can define equipment here in this way because we've created function which receives one block of code. Remove this comma because still it's not a parameter to constructor. So functions are in this case. And spell power is not spell power anymore because we want to call this power from spells function, which is called in context on this array list. So I can remove from extension this items, spells, power, spell power. We don't need this function anymore, but it's good to know how to start with it. And wizard Gandalf, also with brackets. We can remove it. Equipment. Spells. Power. Okay, so this is our small DSL with one example. I will show you. I will start it on bigger code. So it looks like this for now. I think it's more readable like this imperative way earlier. It still worked, as you can see. There's still Super Knight with level 10, Gandalf with level 10, the same power. Knight has 1 this time. And to show you how it's gonna work on this bigger code, I will copy it to our main. So there is lots of more other knights and wizards. There are 8 heroes, 4 battles. And some knight called Black has won this time, right? There were lots of fights, lots of fights. It still has worked. And one thing I didn't mention that if I create a tournament, I need amount of battles which is power of 2. So if I remove 1 battle, I have 3 battles. So it's not a value to creating something like ladder system, right? So if I remove it, it shouldn't work. And it didn't. Fight number must be power of 10, right? So about DSL, I think this is all. I know that it's probably, maybe it was too quick because we haven't so much time and it's maybe a little hard to do fast. But I think that if you see on this code and we'll try to understand it slowly, you will see some similarities, some concepts, and you will see that it's easy to use. And if you want to know more about this DSLs, Kotlin, etc., I encourage you one more time to check this link and check Twitter on this hashtag. Thank you so much.